This section is going to look at the change in human population growth. So the human global population has been showing exponential growth. And if you look at the growth over time, so BCE, 8000 BCE, there's a break here because it doesn't increase much. The global population started to take off around the 1600s, and you can see that it's got that J-shaped curve here. So we are actually still in exponential growth. Although we think in the last century that growth rate has started to turn, so we might be reaching that inflection point fairly soon, to where we'll start seeing slower population growth over the planet. The planet currently has over 7.2 billion people on it, and it's still continuing to grow. You can see little bumps here and there. This one right here is actually the bubonic plague here, and that was such a horrible pandemic that you do see a dip in the population growth there. But because the population was so small at that point, that was a large percentage of the population. I don't think we'll see the same kind of dip with COVID. I think we just might see population growth rates start to slow down a little bit sooner than had been predicted. You can see that the growth rate is different depending on where you are. So first world countries like Europe and the United States, the growth rate is still positive, but it's been slowing down for a while. Third world countries, places where industrialization is still occurring, is in Africa, like this, is still increasing, so their growth rate is much higher. So the growth rate in the different places around the world is not constant. Places that have been fully industrialized, very westernized countries, tend to have lower growth rates than countries that are kind of starting industrialization. And that's the other thing we see around the 1600s, right about here, is the Industrial Revolution, allowing for massive increases in humans' ability to spread out and grow and have a lot of the comforts that we associate with life. So just because the population's growth is not changing doesn't mean that the population is the same as someplace else. So two different places can have this same growth rate, meaning zero growth, and still have a couple of different characteristics. So a zero population growth could be because they have a lot of births, but also a lot of deaths. We might also have zero population growth because we have a low birth rate and then a low death rate. So this might be someplace where very few people are having children, and then most of those children are surviving for a long time. Whereas this would be where lots of people are having children and many of those children are not surviving. The demographic transition from here to here is usually associated with kind of industrialization, increased quality in healthcare, access to education. There's been shown to be a causal link between educating women and birth rate. So when women are allowed to be educated and are educated for longer periods of time, they tend to have children later, and they tend to have fewer children. So we start to see high birth rate countries going from high to low birth rate countries as women become more educated. A lot of the times we will use age structure to look at kind of a snapshot of the population in any individual country. So usually we would do this countrywide based on kind of census data. This is going to take into account gender and age usually. So this might illuminate the way that the population is going to change and the population trends over time. So this is a characteristic of a rapid growth country. So usually you see these triangles. So what this means is right in here is 0% of the population. And left of this is male, right of this is female. So what this shows is that 8% of the population is male and between the ages of 0 to 4. And about 8% of the population is female and between the ages of 0 to 4. So most of these you can see a pretty even distribution between male and female. If you saw something different, that would indicate that one gender is getting proportionately more selection than the other. You might see that in China. And so because there's a large number of the percentage here, these brackets are fairly wide. We can see that people under 25 and under there's a lot of the large population. The reproductive group might be people in this kind of category here who are able to reproduce. And this is a pretty large bracket. So this indicates a population that's going to grow because these are going to become up here, and we're going to start to see some of these getting wider and wider. This indicates a country that's going through growth, but it's pretty slow. So this is kind of a pretty solid column here, where the width of these columns is pretty much the same. Here you can actually see the baby boomers here from when this was taken, and then this is the group of children of the baby boomers' children, and that's why it's a little wider there. So these brackets down here, they don't look like that pyramid. So instead, what we've got is straight lines. So this is continuing to grow. So this population is still getting larger, but it's getting largely very slow. And then last here, we've still got a no growth population. And this looks a little bit like an inverted hourglass, like this. The largest part of the population is mostly past sexual maturity. So sexual maturity being probably these ages here where they're reproducing. This is actually smaller. So this country, Italy right here, is going to have an issue with the working class supporting the older class as these get older. So what you can see is we'll see these trends kind of move up, these graphs. And we've got fewer young people here than we do middle-aged, and we've got eventually we will have fewer middle-aged than we do older people. And so this is a country where there's not really showing much growth at all. So these growth curves are affected differently by infant mortality. So how much structure is in place for children to be taken care of, as well as life expectancy at birth. So some countries, the life expectancy is very long, whereas with social upheaval or disease or no resources, the life expectancy can be much shorter. The lifespan of humans is not changed. The lifespan of humans tends to be about 100 years. The life expectancy is how long we actually expect to live. And since 1950s, the technologies and new medical advancements have increased the life expectancy. So what is the carrying capacity for our planet? We don't know. So there's a range of people who estimate that it's from about 8 billion to 10.5 billion people. Remember, we're at about 7.2 right now. And we think that this is flexible based on what happens. If global climate change doesn't get fixed, we might see that this number drops. If we can come up with resources to expand our resources into maybe Mars, we might see that this number could be expanded. And there are many limits on the human population size, and the biggest limit is resources. So where do we get food? How much land and water and area are needed to sustain people? So you can actually take an ecological footprint quiz. I put one in the D2L shell, so you can see how many planets does it take to sustain your lifestyle based on the way you live your life. Are you using your car a lot? Are you eating a lot of meat? Are you creating a lot of waste? The picture here kind of shows a heat map, so we can see that the countries that are very westernized, the United States, North America, a lot of the countries in Europe, Australia, have a very large ecological footprint. And then we can see most of Europe and Russia and Asia has a pretty moderate, but still larger ecological footprint. And then some of these non-industrialized countries, places in Western Southern Africa, India, China, South America, have lower to moderate ecological footprints.